Hello everyone. So in this session, let us see about preparation of alkenes. So last class we have read about preparation of alkenes. Now we move to preparation of alkenes. So I have here starting from just for naming, we are comparing with alkenes. The first member in that it is we have methane. The corresponding first member in the alkane it will not be formed because it has to form a double bond between C and C. Therefore, let us go to the second member. The second member is 18. So see the last suffix. See the suffix. So the suffix is the ion-based nomenclature. Methane, ethane, propane. In the case of alkanes. Since now you got two carbons, there is a possibility of forming a double bond between two carbons. Hence, the first member in the alkene series equivalent to that of methane we will not be having. Therefore, this ethane correspondent it will be having an alkene by the elimination of one hydrogen from this first carbon and another hydrogen from the second carbon. We will be having the structure like this. So this is the first member in case of alkene, and that is IUPAC, we call it as ethene, and see the suffix ethene. For ANE is in the case of alkane it is ANE, in the case of alkene it is ANE. The other name it will be olefin. So alkanes are also called as olefin. Okay. So let us move to the third member. So third member CH3, CH2, CH3. So this one is propane. So correspondingly we will be having propene. Okay. So like this it will be CH3, CH double bond CH2. So you can see the elimination of one hydrogen from the first carbon and one hydrogen from the second carbon, which forms propene. Okay. Also we can have the line diagram like this. Okay. So this is for propane and this is for propane. Okay. Now we'll go to the little bit higher series. I'll be having, so this is for A. So this is for ene, and here the right part it will be for ene. So now we are in the fourth series. It's butane. So here correspondingly we will be having like this. Butane. Okay, so shall I number the carbon? 1, 2, 3, 4. If the hydrogens are removed from the first and the second carbon, if the hydrogens are removed from the first and second carbon, we will be having this. This is the product. So this we call it as butene. Okay. So this we call it as butene. If or otherwise, if the hydrogens are removed from the third and the fourth carbon, not from the first and second, so you can have like this. So if you see these two products, both are same, just it is inverted, that's all. Therefore, whatever may be the case, it is butene only, and we call it as one butene. Since the bond stands, you have to take the lower carbon atom. So the bond is between the first and the second carbon. So the lowest number is 1, therefore it will be 1 butane. Okay. The other possibility is that the hydrogens can be removed from the second and the third. Okay. So it can be like this. Okay. So this is the hydrogens removed from second and the third carbon. So shall we number 1, 2 here, 3 and 4 here. So what is the name for this? I said we have to go for the lower number. So the bond is between 2 and 3. Therefore this is 2-butene. And we don't have any other options for 2-butene, only one. As like 1-butene we have, this is the option A and this is option B. Here we have two options, and even though both are same, just for option sake I am telling. Both are same, but here in the case of 2-butene it's only one option. Therefore we have here, this is 2-butene and this is 1-butene. Both can be formed. And that is to felicitate further, I'll go for the 5-carbon system. Okay, so I'll enable pen. So we have here 1, 2, so here 3 and 4, 5. So this is propane, sorry, pentane. Okay, now we'll go for the corresponding alkenes. So let us consider the removal of hydrogens from the first and second carbon atom. Also, what is the next possibility? The same possibility can be from the which is equal to the removal of hydrogen from fourth and fifth carbon atoms. Okay, from pentane, so, which produces the same. So as like the previous, you can, there are two possibilities. So this is from 1 and 2 carbon atom. Even if you take fourth and fifth carbon atom, this is same thing. Even if I can put like this, I can. So both are same. This can be option A. Both are same molecule. So what is the name for this? So start from here. So this is 1-pentene. And here, what about here in option B? You should not start from here. This is wrong. You should not do like this. So I'll rub it. So you have to start from here. 1, 2, 3. So I'll take this. So 4, 5. This is the correct way of numbering. The numbering should start in the functional group. The functional group should get the lowest number. Therefore, it's also 1-pentene. Both are same. Again, there is another possibility of moving the hydrogen, and that hydrogens can be. So this is the first. The second can be. It can be the hydrogens can be removed from second and the third carbon, or it can be removed from third and the fourth carbon. So there are two possibilities. Even though in two possibilities, the compound is one and the same. The name of the compound is one and the same. Okay. 1, 2, 3, 4, 5. So shall we name? Can you name along with me? So how many carbon atoms? 1 to 5 carbon atoms. Therefore, it is the parent is pentane and the double bond is there. Therefore, pentene. So what is the lowest for functional group? It is 2. So 2-pentane. Even though it is for third, whatever it may be, second and the third carbon or third and the fourth carbon, whatever it may be, the compound is one and the same. So here, so like this, it's going on. So we'll go for these are the introduction for alkenes, and we know the common general molecular formula for alkenes. So it is H2N plus 2. Okay, this is a general molecular formula for alkane. Suppose if n is equal, let us put n is equal to 2, which means that, sorry, here we'll be having Cn H2n plus 2. If n is equal to 2, C2 H4 plus 2 is equal to C2 H6. So this will be for ethane. So if you come to ene series, What is the formula? Can you guess? From here to here, what we are doing? We are removing two hydrogens. Therefore, the general molecular formula will be HN2N. That's all. If n is equal to 2, if you put n is equal to 2, so it will be C2H4. So and so on and so forth. So like this one. So this is the general molecular formula for alkenes, and so this one is the general molecular formula for alkenes. Okay, now we'll go for the next step. So this is for preparation. So preparation of alkenes. So preparation of alkenes. So we have here this compounds. Can you name these compounds? Can we try to name? So this is the carbon atom number 1. So this is 2, this is 3, 4. 4 carbon system, therefore butane system. So butane, to which an alcohol group is attached. So it is, so you can tell no, it is butanol. So alcohol series, so we have to suffix OL. Alkane means ANE. Alkene means ENE. So alcohol means OL, we have to say, and that is attached to the first carbon. So therefore it is 1-butanol. Okay. So this one, if you take concentrated sulfuric acid, so what is the nature of concentrated sulfuric acid? Can anyone tell? So this oxygen we have to make as so that 1 second. So it is not being removed. So now it has been removed. So H2, that S and oxygen should be of approximately same size. We should not put like this. So SO4. Okay, for that only I am trying. Okay, now I will remove. So H2SO4. So what is the nature of concentrated sulfuric acid? So it removes. So it removes water. So therefore that one is called as dehydrating agent. So sulfuric acid is called as dehydrating agent. So see OH from here and H from here in this second color. So here I will take another color. Here you will be having two hydrogens, one I will write. So this hydrogen and this OH will be moving as a water, and what it will be having? So it will be having as this compound. So this is alkene. So it will be having here as alkene. Okay. So it is a removal of water. So this is what we are going to see, and I'll present the nature of dehydration agent of sulfuric acid in this video. You can see how
sugar in a beaker. Add a small amount of water into the beaker.
What we are eating, what we are using in kitchen, that sugar.
Now slowly add concentrated sulfuric acid into the beaker containing sugar. Observe what happens. Can you see the effervescence? The mixture starts frothing because of the heat being generated by this exothermic reaction. The black mass form.
So I think you have now understood by that reaction how water, see carbohydrates, they are telling it hydrates of carbon. It will be written like this, whether it is glucose, fructose or sucrose. They will tell it is hydrates of carbon. So this is the meaning. Hydrates means water, water added carbon. Therefore, water added carbon is carbohydrates. So hydrates of carbon, if you put concentrated sulfuric acid, what this will do, you know it now. Sulfuric acid removes water. Okay. So removes water. What is left over? Only carbon is left over. So water will be taken by sulfuric acid, carbon is left over, and that is black in color. Okay. So the nature of this one, nature of sulfuric acid is removal of water, removing water. Therefore, this is dehydration. Okay. So now we'll go for some understanding, little bit more understanding from this. See, I have drawn. So this is alcohol. The another one I'll draw. So this one is the also alcohol. So I have drawn here three different molecules of alcohol. Can you differentiate? Can you differentiate between the three? So hope you can do it. One, two, three, four. The numbering system are same in all the things if you consider. So one, two. You cannot go to the top because it ends with three. Therefore, that should not be followed. This is the lengthier chain. Parent hydrocarbon should be lengthy according to AAP. So this is different and this is different. The third one is different. So this one you know it's all are butane system. So it is butanol where the functional group is attached. It is attached to the first carbon atom. So one butanol. This is also butanol. So where the functional group is attached, it is attached to the second carbon. So it is 2 butanol. So this is also butanol where the functional group is attached, it is 2. But the another one is there. What is the next one? You can. So this group, what is this group? So this group is methyl group. So that we have to differentiate. So that is added as 2 methyl 2 butanol. Okay. So what are the difference between these carbon? A carbon attached to only one carbon. A carbon, oh sorry, so a carbon attached to two other carbons. A carbon attached to three other one. This is second and this is third. A carbon attached to three carbons. So this is called as tertiary carbon atom. This is called as secondary carbon atom. This is called as primary carbon atom. And likewise, this is primary alcohol, and this is secondary alcohol, and this is tertiary alcohol. So why we are telling this? See the reaction, dehydration reaction of tertiary alcohol. It is faster than the secondary alcohol. Secondary alcohol is faster than the primary alcohol. That is the rate of the reaction. The rate of dehydration. So the rate of dehydration, the rate of dehydration fastness is like this. Tertiary alcohol is very fast, then the secondary alcohol, which is very fast than the primary alcohol. Tertiary is faster than secondary, which is faster than the primary alcohol. So this is how it goes, and further we will be little more understanding. So I will tell in this. So let us take. Hope you know this is 1 butanol. So we'll go for elimination reaction. So this is sulfuric acid. So here H will take another color. So OH will be removed, and where here one hydrogen atom is there, and that will be removed as water. Both will be removed, and what you have here is a butane. Butene. Okay. So I'll just let us have a little bit twist here. We will have, so this is alcohol attached to first carbon, therefore this is 1 butanol. Now we will have 2 butanol. Okay. So again the same reaction, corn sulfuric acid. Now, can you think which product will be from? What are the products? Is there only one product or is there more than one product will be formed? Okay. See, OH will be removed from here. Okay, I'll take another color. OH will be removed from here. Hydrogen can be removed from this carbon also and this carbon also. Therefore, there are two possibilities. Unlike here, there is only one possibility for one butanol. We have adjacent only one carbon. Here we have adjacent two carbon atoms. So hydrogen can be removed from this carbon, which we can number also 1, 2, 3, 4. Hydrogen can be removed from the 1 or hydrogen can be removed from the 3. So accordingly, we will be having two different products. Therefore, I'll write the products. Okay, the products are this. If it is removed from the 1, it will be like this. If it is removed from the 3, it will be like this. Okay. So, are they different? Yes, they are different because this we name it as 1 butene. So, this is 1 butene. This is 2 butene. Okay, there are two different products which are formed, and this will be the major product. So, major percentage will be formed, and this is the minor product. Okay. Why? And that is what it is termed by Zaitsev rule. So the rule says hydrogen will be removed from the carbon containing lesser number of hydrogens. So that is the rule. So what is the rule? The rule says that hydrogen removed from the carbon, there are two carbon atoms here, removed from the carbon which consists of lesser number of hydrogens. Okay. So this carbon will be having, this is CH3 group. Therefore here we will be having 3 hydrogens. Here we will be having only 2 hydrogens. So comparing first and third carbon will be having lesser number of hydrogens. Therefore, hydrogen will be removed from the lesser number of carbon containing lesser number of hydrogen. Hence, this product will be formed preferably, or otherwise, this is called as highly substituted products. Highly substituted product that will be favored. This is leastly substituted product, so it is least. Okay, this is leastly substituted product. Okay, you can see here. Further little bit I can explain. See here, this is one carbon, this is also carbon. Here you will be having, I'll take another color, two hydrogens here. Here in this carbon, and just for understanding purpose I am drawing. Here you will be having only two hydrogens. Therefore, this is least number of subs. See in this side, you see. Let us take this carbon. So I'll rub this and write. That will be this. This will be better. Okay, that part. So for easiness understanding, I will To the right part I will draw how this looks like. Okay, I'm drawing that portion. C double bond C. Here it will be having only hydrogen. So one side it will be hydrogen, the other side it is two carbons, so it is ethyl group. Ethyl group C2H5. So let us take this portion, this part. I'll write like this. So one side you are having methyl group, the other side you are having hydrogen. One side you have methyl group, the other side you have hydrogen. So this is called as highly substituted products. So this will be always favored, highly substituted. Here will be least substituted products. Therefore this is not favored. Okay. So with that you can understand how this is being formed. Now we'll go for the second kind of preparation for alkenes. So the second preparation. So I'll tell, then we'll go for the name. Okay. So what is the name? How many carbon atoms? 1, 2, 3, 4. So it is 1 chlorobutane. So there are two. So there are one chloro attached to first carbon, one chlorobutane. So now you can have the reagent is this alcoholic KOH. If you put it, so what will be removed? I'll take another color. So from here chlorine will be removed, and from here one hydrogen will be removed. So what you have, I'll returning back to the same color. So we will be having an alkene butene. So what we have done here, we have removed halogen. So halogen was here, that halogen has been removed. So therefore the reaction, what is the name of the reaction? Halogen has been removed. If you remove something, what we will tell? We will tell D. What has been removed? Halogens. Therefore dehalogenation reaction. Okay. So this is dehalogenation reaction. We'll go for the second. The first one is dehydration. The second one is dehalogenation. As like previous, we said like this. There are. I'll take pen. So we have here like this. So this is as we said. So one chlorobutane. So chlorine attached to the, as like we have seen for alcohols. So this is one chlorobutane. This one is two chlorobutane. And this one is 2 methyl 2 chlorobutane. Can you see what type of halogens are these? As like alcohols we have seen also, this is a tertiary halide, and this is a secondary halide, and this is a primary halide. So we have already seen the rate of the reaction for dehydration. The same thing here also, the rate of the reaction, the rate of dehalogenation reaction in the presence of alcoholic potassium. So the rate of dehalogenation reaction. So what is the tertiary halase? It undergoes very fast, than the secondary, which is faster than the prime. So this is fast and this is slow. So this is slower and this is fast. Okay, same thing we have seen in the case of alcohols also. The rate of dehydration, here also the same thing. Another one I want to highlight, as like we have to go for the Zaitsev rule. Okay, I'm selecting that pen. Zaitsev. a Russian chemist. That rules we are going to see. So here, what is this? What is the name for this? So this is 1-chlorobutane. So alcoholic KOH. This chlorine will be removed. Where hydrogen can be removed here only. There is no other possibility. Okay. So what is the product is? Okay. Only one product. Let us go to 2-chlorobutane. The same. So we are treating with alcoholic KOH. So is there any possibility of removal of hydrogens? Yes, there are possibilities. Here we have one hydrogen, second, three, four. Hydrogen can be removed from how many places? It can be removed from two places. Either it can be removed from the first carbon or it can be removed from the third carbon. What does the Zaitsev rule says? So Zaitsev's rule says hydrogen can be removed from the carbon which possesses of lesser hydrogen atoms. So among the 1 and 3 carbon atoms, which consists of least number of hydrogens? Carbon 3 consists of least number of hydrogens. Therefore, we'll write the products. The product is this. This is the major one, and this is the minor one. So this is the major product. 2-butene is the so 2-butene is the major product, and 1-butene is the minor product, as like previous. So far we have seen how many preparations? So we have seen two preparations. So one from dehydrogenation. By taking alcohol, dehydrogenated, you will get alkane. What is the other preparation? The other preparation is dehalogenation reaction. Okay, there are two, and we'll go further. Final one, the third one. The third one is preparation from Kolb's reaction. You remember Kolb's reaction? For alkanes we have taken. So we have taken carboxylic acid, from that we have prepared alkane. The same Kolb's reaction we are using for preparation of alkanes also. But here we are going for dicarboxylic acid. So remember dicarboxylic acid. So this one, a system containing 2-carboxylic acid, dicarboxylic acid. The minimum possibility is this. As like in alkene, we don't have the first, the equivalent of methane. We don't have a system in alkene. Likewise in dicarboxylic acid we don't have for single carbon atom. Okay, we have to go for minimum 2 number of carbons, and that one, the first in the series is this one, and this is called oxalic acid. So the name is oxalic acid. What is the EPC name? How many carbons are there? 2 carbons. What is the parent thing is ethane. So it is, if it is 1 carbon, we have to say ethanoic acid. There are 2 carboxylic acid, therefore di we have to put ethane dioic acid. So that is the EPC name. So we'll go for the next carbon, next higher formula. So it will be like this. So how many carbons are there? 3 carbons. So what is the root? Propane. How many acids are there? 2. So propane dioic acid, oxalic acid, malonic acid. So this is a common name. So we'll go for the next higher formula. I'll add put 2. This is 1, I am putting 2. This one is 1. So how many carbon systems are there? 4. So butane. How many acids? Butane 2. Butane dioic acid. What is this? Succinic acid. Yes, you see. INIC, succinic acid. So like that, the formula goes further. Like I see, if you are not remembering this word, there is nothing wrong. That we can easily remember the IUPAC system. Just count the number of carbon. 4. Butane. How many acids? 2. Butane dioic acid. So see, let us think of Kolb's reaction from this. You remember the Kolb's reaction? Just for remembrance, I'll take the previous Kolb's reaction. So we have to take. So sodium or potassium salts of acids. Okay. So we have to take 2 molecules. It will be like this only, as we remember from the past. So it will be hydrolysis in the presence of electricity, electrolysis. And you remember the anodic and cathodic reaction. So the cleavage, it will be going as carbon dioxide. This will be going as carbon dioxide. This will be a methyl radical. This will be a methyl radical. So each will be attached, and what will be having? You will be having ethane. Okay. So upon electrolysis, so it will be having as a ethane. So remember the previous thing. Now let us go to the here. If the same reaction is conducted with oxalic acid, you think so. So this will be moving as carbon dioxide. This will be moving as carbon dioxide. Nothing will be formed. Okay, this cannot be used. And here also, this will be moving, and this will be removing a methylene radical. So this will be a methylene radical, CH2. CH3 is a methyl radical. This will be there. Okay. So let us take the third one. Here also no possibility of forming any alkenes. We have to go for the 3, succinic acid or butane dioic acid. Okay, I'll take that one in the next slide. So this here it will be a possibility of forming alkene with butane dioic acid. Okay. So this is butane dioic acid. How it goes? So in the same thing with water and electrolysis. Here also you have to take sodium or potassium salts. So potassium succinate. Okay. So upon hydrolysis, so where are the breaking? So here it will be moving as carbon dioxide. This will be moving as carbon dioxide. Here the radical will be formed. Here also the radical will be formed. Already this one bond will be there. A newly formed one radical means with one electron. So here also one electron, there also one electron. So these two will be forming a bond. Okay, how it will be? It will be like this. So CH2, already one bond is there. One radical here, one that forms a new bond, new pi bond. So now you got ethylene. Okay, this is from Kolb's reaction. So there are three preparation we have seen. So the lecture started with the series differentiating between alkane and alkene, and also we have seen up to 5 carbon system. Then we went up on to preparation number one. Preparation number one is dehydrogenation of alcohol to get alkene, and there we have seen the nature of sulfuric acid with this video. And the dehydration reaction, it will be the rate differentiation will be the faster will be tertiary alcohol, then the secondary, then the primary. The same holds good for dehalogenation for alkyl halides. Okay, the next we have seen Zaitsev rule. Hydrogen will be removed from lesser carbon containing lesser number of hydrogens. Zaitsev rule, and it says about which product will be major and which will be least. And next we went on dehalogenation reaction in the presence of reagent alcoholic KOH. And again, distinction between tertiary, secondary, and primary. And Zaitsev rule in the case of alkyl halides. Then we went on to see Kolb's reaction. As like for alkanes, we have seen for preparation of ethylene or ethene with succinic acid. Okay. So next, these are the questions. Predict the major product and state the reaction. So we have to predict the major product for this, and also you have to give the reaction why this has been formed. That is the first question. This is the second question. So I didn't elaborate for cold reaction, but I have put in question so that little bit you can search what will be formed. What will be formed if you use. So you can name this. You can name this. Try and name this. So what will be formed with this product? Okay, so go for these two questions. This is the second question.